Attention! I'm Sergeant Tech, your senior technical instructor for this edition of the Wells Counteroffensive. Why do you need to know this sensitive information? Because, recruit, it's going to give you more ammunition in the fight to grow your business. It's going to give you the straight dope that will help you solve your customers' problems. So pay attention, do you hear me? In every issue, you'll find lots of information that will make your job easier. So make the time to review the whole thing. And if you've got any questions about the material, why, you just let old Techie know. Now, let's recon our mission. I'm only going to go through this one time, so you better pay attention. Today, people, we're going to look at an emission system that's been around since the late 60s. But nobody really paid any attention to it until OBD2 came around. That's because prior to 1970, air-polluting vapors were vented into the atmosphere. The EVAP system, which stands for evaporative emissions, was developed to contain, store, and send these harmful vapors to the combustion chamber, keeping the air we all breathe cleaner. It operates 24/7 while the vehicle is in operation and even when it's parked. The EVAP system includes the sealed fuel tank, the non-vented gas cap, the canister purge solenoid, the canister vent solenoid, the storage carbon canister, and the fuel tank pressure sensor. And here's how it's designed to work. Because fuel evaporates within the tank, the vapors need to be safely removed. Now, to do this, they are drawn through the lines to the storage carbon canister, which can be found near the fuel tank or in the engine compartment. That's where you are going to end up if and you don't pay attention, hear me? When the engine is running, these vapors are purged from the canister and burned inside the engine. I'm not through with you yet, rookies. Do you hear me? Like I said, that's only the theory. Let's look at how today's system really functions. And remember, even though each manufacturer's system may be different, their basic function will be the same. Okay. We've got those evaporated fuel vapors right there in that carbon canister. How do they get purged or removed? When you're cruising down the highway, see, the throttle plate is open. So the PCM or powertrain control module tells the canister's purge valve and canister vent solenoid to open. You got it? Well, when the purge valve opens, the fumes are drawn from the canister and the top of the fuel tank. When the vent solenoid opens, atmospheric air is drawn into the canister, where it mixes with the fumes. This mixture is then drawn into the intake, where it's burned during the combustion process. But if the valves or solenoids don't operate properly, or if there's a hole anywhere in the system, you got some big problems. Now, if the vehicle was born before 1996, you didn't even know you had a problem. But OBD2 solved all of that with the EVAP monitor. That's right, people. We just added another component to the system. Now let's see how it works. It's simple, really. First, the PCM orders the vent canister purge solenoid to close, which automatically seals up the canister and stops any more air from entering. The intake then creates a vacuum in the system, pressure accumulates, and it's measured by the fuel tank pressure sensor. Now, when the pressure in the system is equal to approximately 10 inches of water, the fuel tank pressure sensor tells the PCM, which commands the canister purge valve, to close. And this completely seals the EVAP system. Then the PCM monitors the sensor for any drop in pressure. And if it remains steady, the PCM commands everything back to normal operation. You got that? But If the PCM detects a drop in pressure, it knows there's a leak somewhere in the system. So it determines the size of the leak and sets a pending code. Now, isn't that something? Now that's strike one. If a drop in pressure is detected the next time the monitor is run, that's strike two. The PCM illuminates the malfunction indicator line, also known as the MIL, sets a trouble code, and tells the driver, "Houston, we got a problem." When the trouble codes are pulled from the PCM, the tech is going to find one or more of 14 different codes. Now, y'all pay attention to this, old techie people, because I'm only going through this one time. If it's a P0440, it means the system was unable to achieve enough vacuum. P0441 means there wasn't any flow during the purge cycle. P0442, P0456, or P0457, there's a small leak in the system. Now, if the code reads P0455, there's a large leak. P0443, P0446, and P0449 all mean there's a problem with the purge solenoid. It could be blocked, or it might not be activated. P0450, P0451, P0452, and P0453. They all mean there's a problem with the fuel tank pressure sensor. And if the trouble code P0496 sets, the evaporative emissions are flowing when they're not supposed to. Okay, now that we've looked at the trouble codes, what could be causing that malfunction indicator light to light up? Well, some of the more common causes include a defective or loose fuel cap. The canister is disconnected or it's cracked. The purge and or vent solenoid is defective. There's a vacuum leak. There's a blocked or collapsed hose somewhere in that system. The fuel tank pressure sensor has failed. Or there's a wiring or connector failure. That's what your customer's going through when they encounter an EVAP problem. And now, you have the knowledge to help them solve their problems right the first time. Right? People, I can't hear you. One of the most critical components of the EVAP system is the fuel tank pressure sensor. And when your customer needs to replace any of the EVAP components, Wells Engine Management is the true alternative to any other manufacturer, and here's why. All Wells fuel tank pressure sensors feature precision electronics and circuitry that is laser trimmed for consistent accuracy. Did you hear me? I said laser trimmed accuracy. Every aspect of these sensors is checked before manufacturing even begins, and then checks are conducted and recorded during the process to ensure everything is on track. This includes leak tests and performance tests at elevated temperatures. In fact, Wells fuel tank pressure sensors have been proven to operate to OE specifications or better at temperatures exceeding 200 degrees Fahrenheit. Are you listening? Now, people, when you combine this with the broadest coverage in the business, including fuel tank pressure sensors that fit the 2005 Toyota Corolla or even the 2006 Honda Ridgeline, you can see why Wells Engine Management makes you the one-stop source for all your customer needs. In fact, we've got over 60 more fuel pressure sensors cataloged than our nearest competitor. So when your customers call with an EVAP system problem, there's no reason to tell them it's a dealer item only. People, it's up to you to take back the business that belongs to you. Don't miss it. Next time, we're gonna get the module and coil business back. Hoorah!
Sound of 1, 2, sound of 3, 4, sound of 1,
1, 2, 3, 4. 1, 2, 3, 4.